right.
What kind of phenomenon is that?
Exploring.
That's loving.
All right. So A1 is called Exploring Exponential Models. So we're gonna talk about what an exponential function is. Whoa. Good Lord. There we go. Okay, and we're going to talk about what they look like, so we're going to graph them, and then I'm going to show you how to come up with an exponential equation given 2 points. Okay, so 2 things involved in this section.
I like exploring.
Okay. All right, so the first thing that you need to know is the standard form of an exponential function. Okay, so it goes y is equal to a times b to the x. Okay, so my first question, Kike and Andrew, can you sit back there together without talking? Okay, so my first question for you is, if I have a times b to the x, can't I just multiply the a times the b together?
No, because don't you have to have the x power to both of them?
Yeah, because the b is connected to the x.
Oh yeah, okay, because order of operations says you have to do the exponent first and then multiply times the a. Okay? Alright, so the a and the b are both going to give us information about our exponential function. Okay, so the a, if you are graphing it, tells you the y-intercept. Okay, if you are doing something with word problems, it tells you the starting amount. Okay, which we'll talk about tomorrow.
Are we actually going to do word problems?
Yes, they're pretty simple.
I'm not going to do it.
We'll do them together, don't worry. All right, the b, anybody know what the b does? It's not the x-intercept. It does have to do with the slope of the graph. Okay, it tells you how fast this function grows or not. Okay, it is called the growth factor. Okay, so it is possible to have 2 different types of growths. Okay, if your b happens to be bigger than 1, then the function is going to get bigger and bigger and bigger. Okay, and that's called a growth. If the b value happens to be less than 1, then what would the opposite of a growth be?
Shrink.
A shrink, a decline. They call it a decay. Decay.
All
Yeah.
these words are making sense to me in a different way.
Perfect. So you need to also know that the b value must be greater than 0. Must be greater than 0. Okay, so just realize it's impossible to have a growth of 0 because that wouldn't even make sense, right? If I'm growing at a rate of 0, that doesn't make sense, right? That's just staying the same. Okay, or decaying. A stunt of your growth, right? Exactly. Line. Okay, and you can't have a negative amount of growth because the negative would be eaten up by the a. Okay, so you can't have a negative b.
So you can.
Okay, so in terms of what these look like, a growth looks like this. Okay, the growth function is just like what Colin drew on the board today. Okay, so it starts infinitely close to the x-axis and then grows up and gets bigger and bigger and bigger.
How come it's on the negative side?
Because it keeps going, it can exist in a negative.
Well, I have a question. So, did we ever see a b that's supposedly a negative number?
Can't have one.
B
Not
must
possible.
be.
It just is
You can't do
not
it.
possible.
Not possible.
So,
It can't happen.
how would that look in
It can't exist.
like, I know it can't
not
exist,
possible.
but if you have a equation.
I guess what's crazy?
You can't do it. It's not possible. You cannot do it.
I understand that, but when it's like it's not possible, answer on paper,
Well, I'm telling you, it's not possible. You can't do it.
no, it's not possible, but what the whole like the American drug use that
You can't. Okay, so now what I need you to understand about this graph, okay, is that since this function as x goes to the left, as x approaches negative infinity, okay, it is getting infinitely small, super small, but can never reach 0. Can't have 0 of that. Okay, so what's happening with the graph is there is an invisible line that's keeping the function above it. Okay, it's like a bounded region. Okay, so there's a name for this invisible line. Anybody know what it's called?
Mr. Incredible. No. Twilight, I mean.
Line, the Tropic of Cancer line.
So,
Assumption.
So it's an asymptote.
What?
Asymptote.
I was sorry.
An asymptote.
not.
Okay, so it is a line, an invisible line, by the way,
It's just like my
that
eyes.
the function, not really.
So it's just like my homework. It's there, but it's invisible.
It never reaches. Okay, so right now there is an invisible line at y equals 0. Okay, there's a horizontal asymptote at y equals 0. Okay, so today we're going to keep that at y equals 0. In the next section we're going to move it around. So we'll take our exponential functions and move them up and down and left and right. So that'll take that asymptote with it. Okay. The other function is a decay. Okay, so think about this. If I have an exponential growth, I have something that is getting exponentially bigger. Okay, but if I have a decay, how is that going to look? I'm going to start really big and then get really small. Okay, so that graph is going to start way up here and curl down and get infinitely close to that x-axis again. Okay, so again, there is that invisible line, that asymptote, that the function is getting closer and closer to, but never actually reaches.
So what you're saying is it kind of can be like an airplane going off, but then you get down where you're going down on the like descent airplane, but you never touch the ground.
Yeah, sure.
It's like an airplane's flying and it's just flying.
Okay, so have you guys ever done that that example where you keep dividing by 2? Okay, so for example, like if we have 10 and we keep dividing 10 by 2.
5.
You divide by 2 and 5 divided by 2, and you divide by 2 and you keep dividing by 2, but if you have something and you divide it by 2, you still have something. Okay, so it's just getting exponentially smaller. It will never be 0, but it is getting like anatomically small.
Even if it goes like all the way through time.
Yeah, like an atom, so small.
Miss Nolte, if you
Okay.
take 10 divided by 2 divided by 2 divided by 2 times, you get to 0.078125.
Yeah, but never 0, right? Ah. Okay, so first thing they're going to ask you to do is simply graph these functions. Okay, so I'm going to give you asymptote. Asymptote. And we're going to be doing a lot more with asymptotes in the next 2 sections. Yes. Okay, so on these graphs, this is what I'm looking for. Number 1, I would like you to identify the 2 pieces of the graph. I want you to tell me what is the 4 giving me, what is the 2 giving me, and then you're going to graph it. Okay, so what is the 4? The y-intercept. What does the 2 tell me?
The growth.
Okay, is it a growth or is it a decay? It is bigger than 1, so therefore it is a growth. And that's all I'm going to look at. Okay, if I have like a 200 right there, okay, the idea would be that that function would go really fast, like a rocket. Okay, but I don't really care about the slope of your graph, so I'm not going to be looking for that accuracy. I'm going to be looking at where does it cross the x-axis, and are you drawing a growth or a decay? Yes.
It's bigger than 1, but it's like 0.5. That's
No.
So,
0.5 is less than 1.
so what's not?
So that would be a
so you
decay.
have something about 0.5%.
No, it's decay. Well, if you say it, now it depends on the way you say it. We'll talk about tomorrow with that idea. Okay, so we're going to do word problems tomorrow with if I increase by 0.5%, 50%. You're still increasing, so yeah, we'll talk about that tomorrow. That would be a different growth factor. It's not 50%. We'll talk about it tomorrow, I promise. Okay, so on this drawing, I'm going to start with my y-intercept, which is 4. So I go up to 4, and I have a point there because that's where I cross, right? Jarrett, put that away or I'm going to take it.
16.
Next time I see a game on it, it's mine.
What?
Next time I see a game on it, it's
There won't be a
mine.
good one.
Put it down. Okay. Now how do I draw a growth? What does it look like?
Like a plane taking off.
Like a plane taking off. Okay, fair enough. Good.
Oh, do we have to draw it like that?
Yes.
Absolutely.
Okay, so I should be able to see that the function starts almost at the x-axis. Almost. It's hard to draw that with a pencil, right? Okay. Technically it doesn't touch it, but we all have a little human error.
You're definitely crossing it.
Whatever, that's infinitely close.
Skyla, you have to.
Okay.
Watch your eyes.
All right, let's try one more. Here's your second scenario. If you have y is equal to 3 times 1/2 to the x. Okay, so the two pieces of information that are involved, the 3 tells me what? That is the y-intercept. The 1/2 tells me
Your decay.
it is a decay. Okay, so that is just going to tell me that the graph looks different than the one above.
I don't want to hear you girls talking.
Oh, whatever.
All right, so there is my y-intercept at 3. How do I draw the decay?
Go down.
Why
Okay,
did you
so
go
we
to
start
decay?
high
Because
because
it's less than 1. I thought it was less than 2.
Can't have anything less.
I promise myself.
This
Okay.
is infinitely close.
oh, it kind of looks like it goes back up though, so yeah, it's a little.
No,
Mine-
you
mine
can't
looks
do
pretty
that.
good.
You just can't do
That's
that.
pretty
Okay,
perfect.
yeah, that's right there.
Okay, so we good with that? That is about as far as they're gonna go with that. You're gonna do translations in the next section, so just identifying the two pieces. No, the second part.
Oh.
Okay, remember I said there's two parts, graphing, and then the second part is if they give you two pieces of data, coming up with the model. So, here's the second part. They want you to write the exponential, I'm going to say expo, model, given the 2 points.
Miss Nolte, guess what I'm at right now? 7.4505978
Oh, you're still dividing by 2?
Yep.
Oh, good.
I'm gonna get to 0.
All right, so given 2 points. So I'm going to tell you that there are two ways to do this. Okay, you can do this algebraically, and you can do this using the calculator. Okay, so I'm going to start by showing you how to do it algebraically, and then I'll show you how to do it on the calculator, and then you can choose which way you think is the easiest. Okay? All right, so if I'm going to write the exponential model, which is just a fancy way of saying the exponential equation, given those 2 points, first of all, what does the exponential equation look like?
Y equals
A times b to the x. Okay, so this is the form that we want our equation to look like. So the goal here is that we need to figure out, Skyla Jarrett, what
We're
the a
listening.
value is and what the b value is. Okay, so what I'm going to do is I'm going to kind of break this into 2 steps. I'm going to start by using the first ordered pair, and then I'm going to solve for one of my variables, and then I'm going to use the second ordered pair and solve for the second variable.
I could go for it.
Okay, so step 1, you ready, Jarrett? Step 1. Okay, so step 1, I'm going to use the first ordered pair, which is 2, 4. And if you get an ordered pair, what 2 variables are you given?
X and Y.
An x and a y. Okay, so that means my x value is 2 and my y value is 4. So take those 2 variables and plug them into my exponential model. What would it say? Well, what is y?
4 equals A.
4 equals a b to the second. Perfect. Okay, so simply plugging those in. So right now what I have is an exponential model with 2 variables. I have a and a b. That's not good. Can't solve an equation that has 2 variables. So what I'm going to do is I'm going to choose one of those to solve for, and then I'm going to use that in my second step. Okay, so which one is easier to solve for?
A.
Absolutely A. Okay, so that says a times b squared. So how do I get rid of the b squared?
Cube squared.
You can't square root.
You can square root it. The a is not squared.
Well,
You
divide
have
by
to
A.
divide by it. We're solving for a, not b. So all we're going to do is start by dividing by b squared. Okay, so everybody agree that a is equal to 4 divided by b squared? Okay, so that was first step. Step 2. Okay, in step 2, I'm going to use the second ordered pair. And I'm going to do the same game. I'm going to plug the x in, and I'm going to plug the y in, and I'm going to plug the a in.
Where's the A?
Right there. Okay, so remember, I'm going with y is equal to a times b to the x. What is the y of the second point? 16 is equal to a. What is a? 4 over b squared times b to the third power.
Why is
How
it
did you
16?
come up with that?
Oh, okay. Just
Because
kidding,
now I'm
guys.
using the second step,
Just joke around.
or the second point.
Oh, don't do that. Yeah. Serious or this not here?
Oh, good, right.
Oh, now we only have 2 variables.
Okay, so now I have an equation with 1 variable. It is simply a b, and I can solve an equation with 1 variable. Okay, so just so this looks a little nicer for you, this says 4 times b cubed divided by b squared. That's the same
it's just
thing.
4 over B.
Oh yeah, because you just subtract the exponents. If I have b cubed over b squared, that is just b.
I did something right.
Good job, Jarrett. And now my last step in solving for the b, divide by 4. All right, so we got the b value. We found it. But remember, I still have to find the a value. How do I find the a value?
Plug that in.
Oh, into that blue equation, right? So I can say that b we found to be 4, so 4 squared is, let's see, 16. So the b is 1/4. Okay, so now if I go back to my black equation, the equation is y is equal to 1/4 times 4 to the x.
Where is everyone today?
This is everybody. We're only missing like 2 people.
Oh.
3 people. So what do you think? Not too bad? It's not that easy. All right, so second possible way, grab your calculator. I'll show you how to do this on the calculator.
I'm at 1.136863838 e to the negative 12.
Uh-oh.
And now I can't do it.
Still didn't get 0. All right, you guys ready? Everybody got a calculator. Okay, so the idea with using the calculator is that they have given me data points. I'm going to take those data points, plug them into the calculator, and have it calculate the regression model. Perfect. We've done this before. Where do I go to input data into my calculator?
Y equals.
No, that's where you input an equation.
Right?
Stat is where you go to put data. So hit stat and then enter. Okay, so remember we're going to put our x's into list 1, y's into list 2. So my x values are 2 and 3. Oh gosh.
I don't know how to do this. Oh, there we go.
This is really slow, but.
So 2 and 3?
2 and 3, and then my list 2, my y values are 4 and 16.
And then you go
Okay,
second.
not second. Okay, so now we need the calculator to calculate our statistical thing. No, it would be 4, because the 4 is my y. So see? So my y and my y. That makes sense?
Oh, is it?
Okay.
Expo.
Yeah. Okay, so you're gonna hit stat now. Okay, and you go over to calc, and we're looking for the exponential regression model. So go down, and I do believe it's number 0. Wow, this takes a while to go down.
Wait, where do we go?
Keep going down. Stat, over to calc.
And then 9?
No, 0.
0.
Expo regression. And then you gotta go down and tell it to calculate. And if we did our algebra correct, we should get the exact same answer that the calculator gave us. What do you guys think?
You got the wrong answer. It's 0.25.
0.25 is an exact answer. I prefer fractions, but the calculator prefers decimals.
You really anger me, because you prefer fractions, but Miss White prefers decimals, and it's just angering.
Yeah. So, which way do you guys prefer? So you guys like technology?
I've never once studied it.
Just making sure. Alright, here is your assignments. It is on page 426, and you have 2 through 30 evens.
It's like